Hello students, you are welcome back to Larbi Premium Consults. In today's video, we are going to look at logarithm. So if you are new on this channel, please make sure to like this video. Make sure to like this video, okay? And subscribe if you haven't subscribed to this channel. So anytime we release any video, you will be the first person to get it right away on your device. So without wasting my time, let's zoom through to logarithm in this case. So today we are looking at logarithm. What is a logarithm? We are saying that logarithm of any number refers to the index or the power to which the base must be raised to get the number. Logarithm of any number refers to the index or the power to which the base must be raised in order to get the number. Let's say I have 32. That's my number, okay? Per the concept of logarithm, we are saying that logarithm has to do with what refers to any number to which the base of that number must be raised. Refers to the index or the power to which the base of the number must be raised in order to get what that same number back. That's what we call what logarithm of any number. So I have 32 here. Realize that when we were discussing the concept of indices, we said if I want to write 32 in an index form or index notation form, it becomes what? It becomes 2 multiplied by 2 multiplied by 2 multiplied by 2 and then 1. So we have what? A group of 2 in 5. Right? So we have 1, 2, 3, 4, 5. Okay, so I can write this as what? 2 to the power of what? 5. Now the concept of logarithm here is saying that now for me to get the number, which is 32, it is as a result of the number or the power or the index of, that is this one, 5, being raised by the base, which is a 2, for me to get the number. So this is what we are saying. If I have log to the base of what? This is the base of the base, which is 2, okay? And the number, which is what? 32. If I have log 32 to the base of 2, we are saying that in that case, we are going to get what? 5. Why are we saying that? Because we said the definition of logarithm here is that logarithm of any number refers to the index or the power to which the base, which is 2, must be raised by the power or the index in order to get what? The number. So if you like, take a calculator, punch 32, log 32 to the base of 2, you're going to get what? 5. So the concept here is that here, if I want to write this in an index form as 2 to the power of 5, it becomes what? Per the definition, the base must be raised by the power, which is what? The 5. So it becomes what? 2 to the power of what? 5. Okay? And that's going to give me what? 32. So that's the concept of what? Logarithm. So if I have log of log of b to the base of a, and we are saying that the final is going to be c, I can write this in an index form by saying that here b is equal to a to the power of what? C. I hope you are getting the concept right. So that is the idea when it comes to what? Logarithm. Actually, indices and logarithm are related. Okay, so once you get the concept of indices, logarithm becomes something that is so easy for you to understand. I hope that is clear. So this is what we call the index or the power or the exponent, and we call it to the base. So per definition of logarithm of any number refers to the power or the index or the base to which the base of that number must be raised by the power in order to get what? The number. So that is logarithm of any number. And we have said that if I have log b to the base of a, we are saying that it's equal to c. And if I want to write this in an index form, b will be equal to a carry what? C, because the base is what? The a going to carry what? The power, which is what? The c. And that's what we have done here. So if I also have, let's say, I have log of 16, okay? And let's say here is the power of, let's say, 2. Is that okay? So here it becomes what? If I want to write this, I can say let here be equal to, let's say what? X, okay? So meaning that I can say that 2 to the power of x will be giving me what? 16. Is that okay? So here we count 2 to the power of x, going to give me what? 2 to the power of what? How many groups of 2 should I raise the 2 that will fetch me 16? And you know that one's what? 4. Okay? And now your x is going to be what? 4. So you realize that log of 16 to the base of 2 is going to give me what? 4. So that's the whole concept about what? Logarithm. And one thing we should note here is that at any point in time your logarithm is given without the base not being provided, we assume that it's base what? 10. At any point in time where the logarithm of the number is given without the base, the whole idea is that the base is what? Equal to what? 10. So that is the whole idea about what? Logarithm in that case. So I hope you are getting it right. So if you are getting it right, comment below and make sure to like this video so you can get more engagement on this video. So that is the whole concept about what? Logarithm. That's the whole concept about logarithm. So we know that for logarithm, the base, if it is not provided, let's say we have log, let's say log 9, and it's not provided, the assumption here is that the base is what? In base what? 10. I hope that is clear. So that is the whole concept that we need to understand when it comes to logarithm in that case. So logarithm of any number is the power or the index to which the base must be raised by c in order to what? To get the number. So that is the concept about what? Logarithm in that case. And one thing also we need to note here is that logarithm of negative number does not what exist. So if you like, you can try with your calculator. Let's say we have log negative 16. Key this on a calculator. Let's see. You won't get it right. It will tell you that mass what? Error. Is that okay? So logarithm of any number which is negative does not exist. And as I said, if you have any logarithm of any number without a base, the idea is that it have what? A base of what? 10. So that's the whole concept about logarithm. So logarithm is a way of rewriting a number which is an indicial form. Okay, it's also a way of writing what? A number. Logarithm is also a way of writing a number. As we said, this is also a way of what? Writing numbers. Logarithm also give us a clue about how to write a number. Is that okay? Because based on the indices of a number, that we're able to get what? The logarithm, we're able to also do that logarithm approach also to obtain that number in that case. So that's the whole concept about logarithm. So let's try to answer these questions and see how we can go through in that case. So we are asked to convert the following into an exponential form. They are in logarithm form, so we are asked to convert into an exponential form. So how do you engage in that? So let's see how we go through in that case. So we have log 81 to the base of what? 3. We said the logarithm of any number refers to what? The power or the index to which the base must be raised in order to what? Get the number. So it means that the number is what? 81, okay? So which number should the 3, which is the base, need to be raised in order for us to get the 81? That's what we are interested in. And that will help us to know the exponential form of what? This logarithm. I believe that is clear. So here, since we know the number is 81, it's going to imply that I have 81 here. It's going to be what? 3. And which number should I raise the base, which is a 3, in order for me to get 81? So let's say I don't know. So let's say I represent that variable or that number as well. Let's say what? X. Okay. So for me to write this, therefore I can say that how many groups of 3 can I obtain from what? 8 that I can raise with a 3 so that I can get the 81. We know that for you to do that, it becomes what? 3 to the power of 4. 4. Can take a calculator and let's see whether that is right. And that is going to give more 3 to the power of what? X. So meaning that the indicial form of what? Log 81 to the base of what? 3 is what? 3 to the power of what? 4. That is the indicial what? Form. I hope that is clear. So that's going to be your answer. And that's going to give you what? 81. I believe that is okay. Good. And then the same goes going to do here. Here you ask yourself, the number is what? 1/2. Okay. So which number should you raise by the base of 2 for you to get what? 1/2. That is the whole idea about logarithm. So here it becomes 2 to the power of, we don't know the number, so let's say we begin by, let's say x. I don't know. Is that okay? So how will I write half in this form so that I can know the number that I will raise in order for me to get what? The half by. So meaning that here I can find the inverse of for the half. You know the inverse of the half is what? 2 to the power of what? -1. And that's going to give me what? 2 to the power of what? X. So the initial form of log half to the base of 2 is what? 2 to the power of what? -1. I believe that is okay on your side. Right. So with log base 10, log 0.01 to the base of 10, how do you write this one in an exponential form? So it's going to be, we know the number is what? 0.01, okay? And I want to rewrite this in exponent form or exponential form. So if this is the number, which number should I raise the base of 10 for me to get to the 0.01? So let's see. So I don't know, so let's represent that one by x. So 10 to the power of what? X, okay? So here I can know that here is what? 1 out of what? 100. And is equal to 10 to the power of what? X. I believe you are following. So for me to get this equivalent, I can say that here, this 100, 1 over 100, I can find the inverse form of this 1 over 100 in an exponential form. So I can say that here, it can be 10 to the power of what? -2. Or I can say that straight away, that is 1 over 10 to the power of 2, okay? And for me to rewrite this becomes what? 10 to the power of what? -2. And that is going to be equivalent to 10 to, so meaning that you need to raise the 10 by what? -2. So the x is what? -2. So this is going to be the exponential form for log 0.01 to the base of what? 10. So that is the whole concept that we need to understand. So if let's say we were told that we should convert this exponential form in the logarithm form, that's what should have been what we are having in the question. So that is the whole issue when it comes to the idea of what? Logarithm in that case. So let's take note of that. Let's take note of that. So let's continue to work more examples on what we have learned so far. So let's see example 2. Find the value of the following. Find the value of the following. I log 32 to the base of 2. I log 9, log 27 to the base of 9, sorry. Then let's say log 64 to the base of 8. So how would I write this one? How would I find the value of what? These are the following logs that we have in this case here. So let's see. So with this, all I will do here is let this one be represented by what? X, okay? So for me to write this in an exponential form, we said a logarithm of any number refers to what? The exponent or the power to which the base must be raised in order to get the number. So 32 here is going to be equal to 2 to the power of what? X. And how many groups of 2 can you derive from 32? That we can raise the 2 for us to get what? 32. So here becomes what? 2 to the power of what? 5. And that's going to give you 2 to the power of x. So therefore we can say that log 32 to the base of 2 will be giving what? 5. We're going to what? 5 in this case. We're going to what? 5. Therefore x equal to what? 5. So therefore log 32 to the base of 2 is going to give me what? 5. I believe that is okay. So we do same here. Let's say represent here by, let's say, y. Right? Okay, so here the number is 27. And we need to raise the base. Here is a 9 by y now for us to get what? 27. So here it becomes 27, which is equal to 9 to the power of what? Y. Okay? So how then will I convert these numbers for me to get a similar number that I can find the value of what? Y. So I'll look out for a common value that is similar to, or that's common to both 27 and 9. I can say that here I can derive 3 to the power of 3, and I can also derive here 3 to the power of 2. So the 2 is going to multiply the 1, so it becomes what? 2y. Okay? So since I'm having the base to be equal, therefore I can say that my 2y is equal to what? 3. So therefore my y is equal to 3 out of 2. So therefore you can conclude that log of 27 to the base of 9 is going to give me what? 3 out of 2, or one whole number, 1 out of 2. I believe that is okay, right? And then we have log 64 to the base of 8. So the same rule. Let's say log 64 to the base of 8 be equal to, let's say, z. Okay, so here 64 is going to give me 8 to the power of what? Z. So how many groups of 8 can I derive from 64? That I can raise the same 8 for me to get what? 64. That is the concept. So here it becomes what? 8 to the power of 2. It's going to give me 8 to the power of what? Z. So I can know that I have 8 here, I have 8, they both cancel out. Okay, so therefore I can compare the exponent. So I can see that Z is equal to what? 2, or 2 is equal to what? Z. So therefore we can conclude that log 64 to the base of 8 is equal to what? 2 in that case. So that's the concept about logarithm that we need to understand. So let me add out the properties of logarithm so that our next lesson that we engage on logarithm, look at the laws of logarithm and the applications of the laws in that case. So let me add out the properties of logarithm and let's see how we can clarify that in that case. All right. So properties of logarithm. Properties. There's some few properties that we need to know. Properties of logarithm. Properties of logarithm that we need to know. Properties of logarithm that we need to know. So the first property is saying that if I have log, say a to the base of a, is going to give me what? 1. Why are we saying that? If I have log of a number, let's say a, and having a similar or the same what number as the base a, the idea is that it's going to give me what? 1. So let's prove how we got the 1. So I can say that here, if I have log of a to the base of a, we are saying that it's equal to 1. Alright, so let's see. So I can say that let log of a to the base of a be equal to, let's say, what? X. Okay, so we apply our law. So therefore I can say that a is equal to a carry what? X. Is that okay? Remember, we have a here, we have a here. Law of indices, right? Now the bases are equal. What is the exponent here? For this a is what? It's 1. So therefore we can say that if I have here and here are equal, the bases are equal. Therefore I can also say that the exponents are also what? Equal. So therefore I can say 1 is equal to what? X. So that's the reason why we had log of a number having a similar number as the base as being equated to what? 1. So that's the whole concept about the first. So this is property 1. Then property 2. If I have logarithm of, let's say a to the logarithm of 1 to the base of a, we are saying that this is going to give me what? 0. It's going to give me what? 0. Why are we getting the 0? We apply the same concept that we are going through here. So let's see. If I have log of a, log of 1 to the base of a, let's say that equal to, say, y. Okay. So for me to get a number, which is the 1, I need to raise the a by a certain what? Power. And that's how we're going to have to present as what? Y here. So here, 1 will be equal to a to the power of what? Y. Okay. How then prove that log 1 to the base of a is equal to what? 0. Okay. Realize that we said any number raised to the power of 0 should be giving us what? 1. If you remember that property from indices. I've given the link descriptions. They are all in the video. You can check and then watch. I mean the indices of these properties. You can attend to those ones. So if I raise a to the power of 0, and here a is the power. if I raise a to the power of 0, it's going to give me what? 1. So therefore I have a here, I have a here, so they are equal. Likewise, the exponent is going to be what? Equal. So therefore I can say that 0 is then equal to what? Y. So that's the reason why if I have log of 1 to and now log of 1 to the base, and that's going to give me what? 0. So that's the reason how we had the 0 in that case. So let's take note of that. So this will bring an end to the part 1 of our lesson. So if you really enjoyed this video, make sure to like this video and subscribe so that we can get more mathematics lessons from these topics that can help assist you to excel in your mathematics concepts and any examination be right. So I'll see you in the next video where we discuss the laws of logarithm and its application. Bye bye.